Hello friends, welcome to my channel. So today we are going to discuss the shared storage, how we can configure the shared storage so that we have persistence storage for the pods like in production we have. So last time we discussed about the storage, different types of storage that we can use in our lab, including emptydir, dir, hostpath and PVC. So in that, we use a local path storage class, this one. So this supports only read write once, right? So only at one time, only one node can basically access the node. So if pod is getting scheduled to some another node, then there won't be any persistent storage. So that was the limitation of this local path. So, so today I'm going to configure one NFS server on master node only because we have our own lab, right? So either we can create a new virtual machine and configure it as a NFS server, but we are doing it on our laptop, so limit the memory and other things, right? All the resources. So we will use the master as a NFS server, and we will try to configure a storage class that will support read write many access mode, so that same storage will be redundant over all the different nodes basically. So as I mentioned earlier, I am using a alias for kubectl, that is OC, and right now we have two nodes cluster, so one is master and one is worker. Okay, so let me clear my screen. So let's start. So first thing, we need to configure a NFS server on our this, what do you say, master node basically. So I'm logged into the master node. So let me first install. So first we will install this NFS package. So this is the command to install the NFS package. So okay, so as you can see, I have already installed this software. So you can see it is already installed. So let's do on next step. After that, let's create a directory that will act as a basically for the NFS server, right? So I want this directory to be used as NFS server, so that later on if I need to delete or do anything, right, it will be easier for me. So I'm giving this name. So now let's do one thing. Okay, we need to define the permission as well. So let me define this permission. So I'm giving this permission, I'm giving nobody user and group to no group. So why we are giving this? Basically, in Kubernetes pods, keep on restarting, deleting, and recreating, right? So every time, they will have a different ID basically. So we don't have a particular ID that we can map to this folder, right? So we are giving as nobody user, any user can log in with any group. Okay, so nobody and with no group, so they can access the group. So this is we have given. Now let's give all the permission to that folder. So let's give all the permission 777 to this folder. Okay, so right now this folder is having the full permission. Now the next step is to add entry into the etc export file. Okay, so let me go inside the etc export file. I have already made this entry. So we are mapping this folder that we created. Then we are giving this is our cluster range. As you can see, this is our cluster range. So I'm giving the whole subnet so that any node under this subnet can access this. And we are giving it a read write access, and sync is enabled. Okay, and all these are different parameters basically, so it won't limit the root. It will basically keep the root access. And I am giving I'm enabling insecure as well. I mean, because it's our I mean lab only, so that's fine. But for production, I mean, don't use this insecure feature. Okay, so I have did these entries, as you can see. So now these changes we have done, now we need to apply these changes to the export file, right? So let me do this. Export -rv. So R for recursive, A for all, and V is for verbose. So now this configuration is exported, as you can see, exporting this configuration. Okay, so now let's restart. We need to restart this NFS service so that I mean these new changes are implemented. Sudo systemctl restart nfs-kernel-server. I guess this is right. Yeah. Yeah, this is right. Okay, now let's verify if it is mounted. This is working. Yeah, this is working. So we can see that this folder is mapped to this path. Okay, so this NFS server config is working fine. Okay, so now we have to configure this NFS server in our Kubernetes cluster. Okay, so by default these I mean Kubernetes does not support dynamic provisioning of this NFS, so we need to create one pod, okay, one pod deployment that will act as a exporter. Okay, so let me see. Yeah, so this is the NFS client provisioner, so we need a provisioner here. So this pod will act as a provisioner, so it will act as a dynamic NFS provisioning. It will provide us. So let's go through this YAML file. So this is a deployment, as the name suggests, and this is the name of this deployment. We are configuring it in our default namespace. Replica is one, strategy is a recreate basically. These are labels, as you can see. So we are giving this a service account name. Okay, so this is the service account that will be used to I mean talk internally with the cluster. This is a container and this is the image, and this is the volume mount that we have given, persistence volume. Now this is the important part where we have to define our NFS server details. Okay, so you can see this is our NFS server IP, that is 1.3, that is our master IP, and this is the folder that we created, right? So this is the path that will be used for the NFS server. Okay, similarly under volume also we configured this server and this path. So let's apply this deployment and see if it is working. Yeah, it is working. Okay, it came up. So that service account I have already created. Okay, service I already created the service account. I think that's why this pod came up. Service accounts. So you can see this service account is already created. I was saying get service account. No YAML. So this was already created earlier. So it will use this service account to talk with the inside the cluster. Okay. So this is, I mean, this is a simple command. I mean, we haven't done anything. We just created this service account, and this service account is mapped into the deployment pod. Okay, so till now what we did, we configured the nfs server. We configured one uh, provisioner in Kubernetes because by default there is no dynamic provisioning for nfs server. So we created an nfs server. Okay. So till now we are done with this our nfs configuration. Okay, now we need to configure the nfs client on the particular nodes, okay, where we want to use this nfs server. Okay, so I will basically in our case we have to do it on master and node as well. Okay, so I will use my master node as well for the uh, scheduling. Okay, so we need to do it on the both these nodes. Okay, so let me do I will install this client. I already installed this client, so it should be fine. So now let's go back to the worker. Okay, and install here as well. Okay, so it is done here as well. So let me log into the master 0. Okay, so now client is installed on both the nodes. Okay, so it seems it's working fine. So now we have to the next step will be to configure the storage class basically. So let's do cat, okay, cd, let me go to my folder, work, nfs cat storage class YAML. Okay, so now we will create a storage class. So it is so this is the kind, so this is the name of the storage class, so we'll be using ReadWriteMany as the name says. So this is the provisioner that we'll be using. So the deployment that we created, right, that will act as a provisioner, and it basically it will the storage class will point to that deployment, and the deployment will point to that nfs server. Okay, so that's how this our nfs server will be mapped to the storage class. Okay, so reclaim policy is delete. So once the pod is deleted, I mean the pvc will be deleted. Okay, and the volume binding mode is immediate. So let's apply this storage class. Okay, let's see, let me clear this. OC get, let's see. So as you can see, this was our earlier local path, and now we have created this nfs-rwx. Okay, and the provisioner is this one, nfs-subdirectory reclaim policy. So this storage class is created now. Okay, so till now we are done with our storage class. So we have configured the nfs storage basically in our Kubernetes cluster. So the next thing will be to test basically this whether this storage class is working or not. Okay, so we need to create a PVC. So what we can do, we can create a PVC, so it will dynamically create a PV in the backend. Okay, so we don't have to manually create the persistent volume. So let's create this PVC. So let's go through quickly with the YAML file. So this is the name of the PVC. We are giving read write many, so multiple node can read and write to this PVC. So this is the storage class name, and this is the storage class that we configured, right? So it will directly go to that storage class, and it will then map to that nfs server that we created. And this is the storage size that we are requesting. So I mean, it is a lab, so I'm not using too much of the size. So let's do let's apply this PVC. Okay, before that let me show you OC get PV. There is nothing, right? OC apply hyphen PVC YAML. Okay, so it is created. Now let's see get PVC. So you can see this PVC is created and the state is bound, because in storage class we had the immediate binding mode, right? So and this is the PVC, but this is the size, and you can see the access mode is read write X. Okay, so our storage is working fine. Okay, now let's verify this with the help of pods. So I have already created one YAML file, so let's go through this. So guys, I'm creating these YAML files because it takes too much of time to create during the video, and it will be boring, right, to go through all these details. So I'm creating it earlier so that I can reduce the time of the video, and it won't feel boring, right? It's just typing and copy pasting and doing the changes as per our requirement. Okay, so this is a deployment. The name of the deployment is nfs test. So this is the nginx label. So we are creating two replicas. Okay, and these are all labels. So the image is app image nginx. So the name of the container is app. Okay, so this is the volume mount. So it will mount this path on the container, and volume, it will use the persistent volume claim that we created nfs-pvc. Okay, so let's apply this deployment and see. Let me clear oc apply -f pod oc get pods. Okay, it's container creating, so it will try it. Okay, one pod came up, so this other pod will also came up. oc get pods. Okay, so we can use a watch command. oc get pods -o. Right, let me see why error image pull, why it is coming error image pull. Okay, oc describe pods nfs-test. Pulling image in nginx. Unpack image or fail to pull image. Not sure why this is coming. It is able to fetch the image from one node, but why it is not able to get it from here? Okay, do me one thing. For YAML file, this image is already present on the system, I guess, because I have used many times. So image pull policy, if not present, let me, so it will not try to download if it is not present. I think in my this cluster I'm having some issue with the master node. It keeps on reconnecting, if you see. So that's why I logged in via the worker node, and then I SSH on the master node. So that can be the reason it's not able to basically download. I need to fix that. Okay, so let me apply these changes again, whatever we did, right? Okay, so now these boards are coming up, right? Yeah, now it's came up. Okay, let me clear this. So as we can see, our both the ports are up. One port is on worker node and one is on master node. So both the pods are sitting on different nodes, right? So now we can check whether this storage class that we configured right with ReadWriteX, whether it supports persistent storage over different nodes or not. Okay, so let's log into the one of the nodes and try to create a file. Okay, bash. So varlib, what was the path I gave? Okay, sorry, I forgot the path. Okay, cat pod. Oh, yeah, users share. This is the path. Okay, so let me do. Okay, I came inside the path. There is nothing. So what I'll do, I'll deco hello. Hello, ReadWriteMany-RWX PVC. Okay, and I will rewrite it to file called test. Okay, so if I do a cat, I can see the content here, right? Hello. So let's see if the same file, if I can see on the another port, right? Then it means both the pods are sitting on different nodes, but still they can share they are sharing the same storage. So let's log into another node. cd user share nginx html get test. So we can see. So both the pods are sitting on different node, but still they are using the same persistent volume, right? So let's go, let's do this. Let's try to delete some pod and see if that pod comes up, right? And it still has the same data. OC delete pods. Let me delete this pod. Okay. OC get pod -override. So as you can see, this pod has come up. So OC execute -i users share. What was the path? I forget again. User share. Okay, I forgot. Sorry, let me do the CAD again. Nginx. Okay. cd usr share nginx html cat test. So as you can see, the pod was deleted and it was recreated, but still it can access the same data. So now you can see that we have successfully created the storage class with a shared storage of NFS server, and we tested basically that pods are sharing the same persistent volume. So even if the pods are getting deleted, the state is persistent. So I'll just brief again what actually we did. So first we created a NFS server on our master node. Then after that we created a provisioner in our Kubernetes cluster so that it can basically provision the NFS server inside our NFS cluster. So we have given these IP addresses of our master node where we configured the NFS server. After that, we created a storage class so that it can use to that NFS server. After that, we created a pod and PVC just to verify whether our storage class is working or not. Okay. So right now we have two storage classes. One is local path and one is having uh, basically a shared storage, that is NFS, that will work on the multiple nodes basically. Hope you got some learning here, and see you in the next video. Bye.